if we plot the velocity of the marble moving through the water versus the net force, we find that the force goes up faster and faster as the velocity goes up. Now, it makes sense, even though it was the net force that we controlled and the velocity that depended on the net force in the experiment, to ask ourselves how net force depends on velocity. Because a lot of times we move something at a given speed through a fluid, and we want to observe the net force, a boat moving through the water, an object descending in the water, reaching a terminal velocity, and so forth. So we hypothesized from the shape of the graph, and the graph really did have a shape that looked a whole lot like this, that this might be a power function relationship with a force proportional to either the square or maybe the cube of the velocity. And in fact, physics gives us some reason for expecting these kinds of relationships. The reason being that as we move through the water at an increasing velocity, we move more water out of the way to get through the water, and the water that we move actually moves faster. By considering the proportionalities involved, it might be proportional, it might be the force is proportional to the square of the velocity, or maybe even the cube. Because remember, as we move water out of the way, its kinetic energy goes as the square of the velocity, and the amount of water we're actually moving is another factor of the velocity. That might well give us a cube, but for other reasons maybe it's just a square. Without going too deeply into those reasons, we might at least expect these things to be plausible. A little bit of confusion. Yeah, so I'm going to stop this video here. I think we're in the wrong place, but maybe not. Let me think about what's going on here. For a 2-centimeter marble, we derive to fit a power function. You can use a graphing calculator to do that sort of thing also. A power function fit for a square function fit the data quite well, and we got a force that was on the order of 0.03 Newton second squared per meter squared times the square of the average velocity. Now when I say on the order of for a 2-centimeter marble, our results varied from maybe about 0.2 to 0.4 Newton second squared per square meter. So they weren't really precise and really consistent. This varied over several different lab groups, and we haven't done the experiment with a great deal of care over controls and so forth. The different marbles with the glue on them and so forth had different dynamic properties and so forth. So we didn't really correct for those properties.